Let's get
psycho,
logical,
psycho,
logical.
Hey everybody, welcome back. I'm glad to have you here. Today we are going to be talking about factorial designs, and then shortly after we're going to talk about how to analyze them using factorial ANOVAs. So a factorial design, it sounds complicated, but in reality it's just a description of what you get when you have multiple factors in an experiment. Now, what's a factor? Well, a factor is simply an independent variable. It's something that you manipulate in the experiment. So, if you are interested in whether or not brightly colored walls makes kids more excited to do an activity, then color of the walls is a factor, right? But it might be the case that time of the day makes a difference too, right? So maybe in the morning the bright walls make a big difference, but in the afternoon, after they've been hanging around the walls all day and they're kind of tired, maybe they don't make as big of a difference. So that would be another factor. So a factorial design just means what happens when you have more than one independent variable in the same experiment. And we do this kind of thing all the time, especially in psychology. Usually, you'll encounter these situations where someone does an experiment, and in psychology, you may have heard the expression stand on the shoulders of giants. That's a fairly common phrase in scientific circles. And the basic premise is that other people have done really cool work, and you are going to stand on their shoulders, as it were, take what they did and build upon it, ever expanding the bubble of knowledge in science that we have. And so this idea comes into play because a lot of times people do an experiment and they'll have some independent variable that they've manipulated. Well, you might come along and you might say, well, maybe that result is true, but I wonder if it would still be true under the following conditions. Right? So let me think of an example. Imagine that you were looking at data that looked at driving performance after sleep deprivation. So there were these studies that have been done where they deprive people of sleep and they put them in a driving simulator and they measure how quickly they brake. Right? And they've shown that being sleep deprived makes you it impairs your braking ability as much as consuming alcohol beyond the legal limit. So, you might be thinking about this and you think, yeah, well, that's great, but I wonder if that would be true if we gave people caffeine. Maybe we can counteract this effect by giving them a cup of coffee or an energy drink or something like that. So what you might do is you might say, okay, well, what difference, so you might design an experiment where you say, okay, we're going to take two groups of people. One group is going to be sleep deprived and the other is not. That's one factor. And it has what we call two levels. So levels are just what are the different conditions within that independent variable. So in this case, if we have a group that was sleep deprived for 24 hours versus a group that just woke up from a normal full night's sleep, then those are our two conditions. So those are the two levels of sleep deprivation. Now we might then combine that with maybe two levels of caffeine. Maybe we could do a no caffeine or 0 milligrams caffeine versus 100 milligrams caffeine, which is usually what you get approximately in a cup of coffee. Right? So give them a cup of coffee and see if their driving performance is rescued. All right, so now we have two caffeine conditions and two sleep deprivation conditions. And so we have what we call a 2 by 2 factorial design. Because there are 2 sleep conditions, 2 caffeine conditions, that makes a total of 4 conditions. Right? No sleep deprivation and no caffeine, no sleep deprivation with caffeine, sleep deprivation with no caffeine, and sleep deprivation with caffeine. Right? So that's 4 total conditions. Okay, so let me, I've created a little Excel file here just to kind of help us organize things. And I wrote down this sort of rule of thumb. You could think of the effect of blank and blank on blank, where the first 2 blanks are independent variables, and the last blank is your dependent variable, is the thing you're measuring. Right? And so in this case, we have the effect of caffeine and sleep on driving performance. So we're going to have 2 levels of caffeine and 2 levels of sleep to give us a 2 by 2 factorial design. What would happen if what if we thought a cup of coffee isn't going to do it? If you're 24 hours sleep deprived, you're going to need more than that. So we give you 1,000 milligrams of caffeine. Well, not only is that probably going to blow the person's eyeballs out of their sockets, it also changes what we call it. Now it would be a 3 by 2 factorial design. What if we added a third independent variable? Well, guess what? We could add a third one. We could do, let's say, experience, right? Maybe truck drivers have to do a lot of driving while they're sleep deprived, and therefore they have a lot more experience. So maybe we have experience. We have inexperience and experience. Well, now we would have a 3 by 2 by 2. And you can see where this is going, right? You can have as many different factors with as many different levels in principle as you want. Now, just to keep things simple, I'm going to stick with just a 2 by 2 design because there's another concept that we need to incorporate here, and that is the idea of what we call main effects and interactions. And the basic idea is we want to find out what effect caffeine has on its own without paying attention to the sleep. And we want to find out what effect sleep has on its own without paying attention to caffeine. Those would be what we call main effects. However, we might also see an interesting pattern of results where that sleep deprivation had one outcome when there was no caffeine and a completely different outcome when there was caffeine. In other words, you might expect, in this case, what I would expect is, if my hunch is right about what caffeine is going to do, then 0-hour sleep deprivation, they're going to drive pretty well. Add a little caffeine in there, it's not going to make much difference. 24 hours without caffeine, they're going to do really poorly. We know that from the previous results. However, I think this group, the 100 milligrams caffeine after 24 hours sleep deprivation, maybe they will perform just as well as the ones who had caffeine or no caffeine, but no sleep deprivation. In this case, you can't understand the effects of, you can't explain the results based purely on what we know about caffeine or purely what we know based on sleep deprivation. We have to have some kind of combination of the two, because it seems like it's the case that sleep deprivation has detrimental effects unless they are under the influence also of caffeine. So this kind of effect is what we would call an interaction. So we have, in this 2 by 2 design, we have 2 main effects and a possible interaction. So let me show you an example of what what this might look like in graphic form. So I've got just this simple little graph I'm going to make. I'm going to insert and put a little bar graph here. And I'm just going to put some numbers. We're going to put breaking latencies, average breaking latencies. And let's say if they're not sleep deprived and they don't have any caffeine, well, we're going to put their breaking latency at, let's say, 523 milliseconds. Now, if they're sleep deprived, that latency is going to go way up because that means it's taking them longer. So let's say it delays them by a full second, 1.478, or let's see, 1,478 milliseconds. Ooh, okay, so you can see on our graph, well, let me adjust here. On our graph, you can see if they weren't sleep deprived, they were much faster than if they were sleep deprived. This is the amount of time it took. So we're going to call this, we're going to add an axis title here. Breaking time in milliseconds. Okay. We don't need this, and sleep deprivation. Okay. Now, what happens in our caffeine group? Well, you might see that if they're not sleep deprived, giving them caffeine probably doesn't affect their performance that much. So maybe we get something like 601 milliseconds on average for that group. But if they're sleep deprived, maybe you get that little bit of extra arousal, even though they're sleepy. You get something like this. Oops. Okay. So now, if we look at this, then you'll notice that caffeine by itself, right, so ignore the deprivation, just look at the groups that got caffeine. So the groups that got, the orange bars are the groups that got caffeine, and the blue bars are the groups that didn't. If you just look at the blue bars and kind of took an average, you'd have to think of a weighted average if the sample sizes are unequal here, but if you just kind of average them, the average would be something like right here, and then the average of the orange bars would be something like right in this area. And to me, that doesn't look like a very big difference. And I don't have any error bars here, but I'm just going to say maybe that isn't significant even. If you sort of took the average of the blue bars and the average of the orange bars and you put them together, you might not see much of a difference. So we would say that there's no main effect of caffeine. Likewise, if we looked just at the effect of sleep deprivation without the caffeine, so let's take now, whereas before we looked at the orange bars versus the blue bars, now we're going to look at the not sleep-deprived bars and compare them to the sleep-deprived bars. So let's say we average these two, and they're going to be something like right here, in that vicinity. If we average these two, it's going to be something like right there. So that's kind of here to here. There might be a difference there, but I suspect there might not be. So you may or may not have a main effect of sleep deprivation on this one, but probably not. If we're going to be conservative, we'll say there probably isn't. Okay, but that doesn't mean that sleep deprivation, that caffeine has no effect and sleep deprivation has no effect. What it means is sleep deprivation can be understood, the effects of caffeine and, let's see, the effect of sleep deprivation on driving performance can be understood by looking at the influence of caffeine. So if we look at our the difference between what changes from the not sleep deprived without caffeine, the not sleep deprived without caffeine to the sleep deprived without caffeine, is that amount of change, this big change here, different from the amount of change you get when you are not sleep deprived with caffeine and not sleep deprived, or when you're sleep deprived with caffeine and not sleep deprived with caffeine, right? The point is that the difference between the change that you get from changing sleep conditions is huge when there's no caffeine, but it's not very huge when there is caffeine. And this is what we would call an interaction. Now I've made a couple of other, put a link to a couple of other videos on the Blackboard site just to help you have a few more examples of this. I don't want this particular video to go on for too long, but that's the basic idea. Factorial design is when you have multiple independent variables, and you can have as many independent variables in principle as you want, and each of them may have multiple levels. If we're talking about between groups designs where we have different participants in each group, then if you want to find out how many groups you have, you just simply multiply the number of conditions and by the number of levels out. So if this was a 2x2 design, that would mean we had 4 groups. So that's the basic story here, and I hope this helps. Let me, before we move on, let me give you 1 or 2 more examples. What if you saw, so this first example had maybe a main effect of sleep deprivation, no main effect of caffeine, but it definitely had an interaction because this difference is much bigger than this difference. I'm going to change these numbers up a bit and see how the situation changes. Right. What if we got something like this? Right. Now we have, this would be an interesting result. Here, when you don't have caffeine and you're not sleep deprived, you perform kind of poorly, or no, you perform well, fairly fast breaking time. But it turns out if I don't sleep deprive you, but I give you caffeine, maybe you're just so wired out of your gourd or whatever, it distracts you and it causes you to have a longer breaking time. Right? So now we went from here to without caffeine, we're performing well. With caffeine, we're performing poorly. I didn't change the other 2 bars, so now when you have no caffeine and you're sleep deprived, you perform poorly. But if I give you the caffeine, you improve. So in this case, if you look at the case of the two bars without caffeine, you have an increase in performance. And if you look at the 2 bars with caffeine, you get a decrease in performance with the more caffeine. So what is the effect of caffeine? Well, if you took the 2 groups that had no caffeine and sort of averaged them together, and the 2 groups that had caffeine and averaged them together, the differences are going to come out in the wash so that they're roughly about the same here as they are here. Likewise, if you look at the effect of sleep deprivation and no sleep deprivation, right, the ones that are sleep deprived, one of them's high, one of them's low. The ones that are not sleep deprived, one of them's low, one of them's high. So if you look at the effects of sleep deprivation, not much to it. So there wouldn't be any main effects here in a graph like this. But if you look at the interaction, that's where you pick up the difference. Because if you have no sleep deprivation but high caffeine intake, then you get a reduction in performance. If you have no caffeine but high sleep deprivation, you get a reduction in performance. Right? So it's only under those two very special conditions that you get a reduction in performance. A similar idea that might make sense to some of you is basketball players. Maybe you're interested in measuring how good basketball players are, and you want to look at the influence of height and the influence of the position that they play. Well, it turns out it's if you are the taller you are, the better you might be at playing basketball. But doesn't that depend on the position that you play? So, for example, if you're a center, you want to be really tall. But if you're a guard, then you probably don't want to be so tall. And so your height is going to not be the only determinant of how good you are at playing basketball. Your position will be another factor that's interacting with it. Okay, I think that's enough from me. You can check out some other videos to try, and if you need a few more examples. And when we come back in the next video, I will be generating some data and analyzing it using JASP, a free software. And then we'll write up the results. Okay, see you next time.